Every single day, American aquaculture facilities produce over 2 million pounds of tilapia, making it the fourth most consumed fish in the United States. From massive indoor recirculating systems in the Midwest to sprawling pond operations across the South, this remarkable industry has transformed a humble African freshwater fish into one of America's most important protein sources. But have you ever wondered how farmers can raise millions of fish in controlled environments while maintaining perfect water quality and optimal growth rates? What does it take to transform tiny tilapia fry weighing less than 1 gram into market-ready fish averaging 1.5 pounds in just 6 months? How do modern processing plants handle over 50,000 fish per day while maintaining the strict food safety standards that keep this affordable protein on dinner tables across America? And why has tilapia become the poster child for sustainable aquaculture in a world increasingly concerned about overfishing our oceans? Welcome to AgriCraft, where we explore the cutting-edge technologies and innovative practices that feed our nation. I'm your host, and today we're diving deep into the fascinating world of intensive tilapia aquaculture and processing. From breeding tanks to grocery store freezers, we'll uncover every step of this remarkable agricultural journey that's revolutionizing how Americans think about fish farming. All will be revealed in this video. The story of tilapia in American agriculture begins with an unlikely hero, a group of hardy freshwater fish native to the Rift Valley lakes of East Africa. For thousands of years, these cichlids thrived in the challenging waters of Lakes Victoria, Malawi, and Tanganyika, developing remarkable adaptability that would later make them perfect candidates for commercial aquaculture. Ancient Egyptian hieroglyphs dating back over 4,000 years depict tilapia fishing, and some historians believe these fish were among the species that fed the multitudes in biblical accounts. But tilapia's journey to American farms began much more recently. The first introductions occurred in the 1950s when Auburn University researchers brought several species to Alabama for experimental purposes. What they discovered was extraordinary. Tilapia could tolerate water conditions that would kill most other fish species, grew rapidly on inexpensive feed, and reproduced prolifically under controlled conditions. The transformation from research curiosity to commercial powerhouse accelerated dramatically in the 1980s. Forward-thinking aquaculturists recognized that tilapia possessed all the characteristics needed for intensive farming: fast growth rates, disease resistance, efficient feed conversion, and mild flavor that appealed to American consumers. By the year 2000, domestic tilapia production reached 10 million pounds annually. Today, that number has grown to over 150 million pounds per year. The economics of tilapia farming are compelling for American producers. Unlike traditional agriculture that depends on land availability and weather patterns, aquaculture operations can produce consistent yields year-round in controlled environments. A single acre of intensive tilapia production can generate over 100,000 pounds of protein annually, compared to just 400 pounds per acre for beef cattle. This incredible efficiency has attracted investment from major agricultural corporations and innovative entrepreneurs across rural America. What makes the American tilapia industry unique is its focus on sustainability and food safety. While many countries rely on extensive pond systems that can impact local water resources, American producers have pioneered recirculating aquaculture systems that use 99% less water than traditional methods while producing zero discharge to surrounding environments. These closed-loop systems represent the future of responsible protein production. The global context is equally impressive. Worldwide tilapia production exceeds 6 million tons annually, making it the second most farmed fish species after carp. China dominates global production with over 1.8 million tons per year, but American farms are rapidly gaining market share by focusing on premium quality and sustainability standards that exceed international competitors. The journey from breeding stock to market-ready fish begins with careful genetic selection in specialized hatchery facilities. Commercial tilapia operations rely on carefully maintained broodstock populations that have been selectively bred for rapid growth, disease resistance, and optimal body conformation. These breeding programs represent decades of genetic improvement that rival the sophisticated plant breeding programs used in traditional agriculture. Most American tilapia farms begin with Nile tilapia, scientifically known as Oreochromis niloticus, though some operations also work with blue tilapia and Mozambique tilapia varieties. The breeding process starts with mature fish averaging 2 to 3 pounds that have been proven to produce high-quality offspring. These broodstock fish are maintained in temperature-controlled systems with optimal water quality parameters and specialized nutrition programs designed to maximize reproductive performance. The spawning process occurs naturally when water temperatures reach the optimal range of 78 to 84 degrees Fahrenheit. Female tilapia are mouth brooders, meaning they incubate their eggs and protect newly hatched fry in their mouths for the first several weeks of life. This remarkable parental care system results in higher survival rates compared to most other fish species, making tilapia ideal for commercial breeding operations. Hatchery managers carefully monitor breeding tanks for signs of spawning activity, which occurs approximately every 4 to 6 weeks under optimal conditions. Once females begin showing enlarged throat pouches indicating they are carrying eggs or fry, they are gently transferred to specialized incubation systems where the young can be safely collected without stressing the parent fish. The newly hatched fry, measuring just 8 to 10 millimeters in length, require immediate attention in carefully controlled nursery systems. Water temperature must be maintained at precisely 82 degrees Fahrenheit, while dissolved oxygen levels are kept above 6 parts per million through intensive aeration systems. These tiny fish are extremely vulnerable to water quality fluctuations that adult fish would easily tolerate. Feeding programs for fry begin with specialized starter diets containing over 50% protein from carefully selected marine and plant sources. The feed particles must be precisely sized to match the tiny mouths of newly hatched fish, with particle sizes starting at just 1/10 of a millimeter. As the fry grow, feed sizes are gradually increased while protein levels are adjusted to optimize growth rates and minimize waste. The nursery phase typically lasts 4 to 6 weeks, during which fry grow from less than 1 gram to approximately 10 to 15 grams. This rapid growth requires intensive management, including frequent water quality monitoring, precise feeding schedules, and careful observation for signs of disease or stress. Successful nursery operations achieve survival rates exceeding 90%, a testament to the sophisticated husbandry techniques developed by American aquaculturists. Environmental control systems in modern tilapia facilities rival those found in the most advanced manufacturing plants. Recirculating aquaculture systems use sophisticated filtration technologies, including mechanical filters, biological reactors, and UV sterilization units to maintain perfect water quality throughout the production cycle. These systems can process thousands of gallons per minute while removing waste products and maintaining optimal dissolved oxygen levels. Temperature control represents one of the most critical aspects of tilapia cultivation. Unlike warm water pond systems used in tropical regions, American operations must maintain optimal temperatures year-round, regardless of outdoor weather conditions. Advanced heating systems using natural gas, propane, or geothermal energy maintain water temperatures within narrow ranges that maximize growth rates while minimizing energy costs. Automated monitoring systems track dozens of water quality parameters around the clock, alerting managers to any deviations that could impact fish health or growth performance. Computerized control systems can automatically adjust feeding rates, aeration levels, and water exchange rates based on real-time data from sensors throughout the facility. The grow-out phase represents the longest portion of the production cycle, typically lasting 4 to 6 months as juvenile fish develop into market-size adults. During this period, fish are moved through progressively larger tanks or ponds as they outgrow their previous accommodations. Stocking densities are carefully calculated to maximize production while maintaining optimal water quality and fish welfare standards. Feeding programs during grow-out utilize high-performance commercial feeds formulated specifically for tilapia. These feeds contain precisely balanced ratios of protein, carbohydrates, fats, vitamins, and minerals needed to support rapid growth and optimal health. Feed conversion ratios in well-managed operations average 1.4 to 1, meaning fish gain 1 pound of weight for every 1.4 pounds of feed consumed. Advanced feeding systems deliver precise amounts of feed multiple times per day based on water temperature, fish size, and growth targets. Automated feeders can distribute feed to dozens of tanks simultaneously while monitoring consumption rates to optimize feeding efficiency and minimize waste. Some facilities use underwater cameras and artificial intelligence systems to observe fish feeding behavior and adjust feeding programs in real time. The harvest phase marks the culmination of months of intensive management and represents one of the most critical periods in the entire production cycle. Timing is essential, as fish must reach optimal size and condition while maintaining peak freshness for processing. Most commercial operations harvest fish when they reach weights between 1 and 2 pounds, though some specialty markets prefer smaller or larger sizes. Harvesting operations typically begin before dawn, when water temperatures are coolest and fish stress levels are minimized. The process starts with gradually lowering water levels in grow-out tanks while maintaining adequate aeration to prevent oxygen depletion. As water levels drop, fish concentrate in smaller areas where they can be efficiently captured using specially designed nets and harvesting equipment. Seine nets made from food-grade materials are carefully deployed to gather fish into concentrated groups without causing injury or excessive stress. Experienced harvest crews work quickly and efficiently to minimize handling time while ensuring that every fish meets quality standards for processing. Fish showing signs of disease, injury, or poor condition are immediately separated and excluded from the harvest. Live transport systems maintain optimal conditions during the journey from farm to processing plant. Specialized trucks equipped with aeration systems, temperature control, and water quality monitoring equipment can transport several thousand pounds of live fish, while maintaining near-perfect survival rates. Transport times are minimized through careful logistics planning that coordinates harvest schedules with processing plant capacity. Some of the largest operations have processing facilities located directly on farm sites, eliminating transport stress entirely and ensuring maximum freshness in finished products. These integrated operations represent the pinnacle of efficiency in tilapia production, controlling every aspect of the supply chain from breeding to retail packaging. Water quality management during harvest is critical to maintaining fish health and product quality. Specialized harvest tanks maintain optimal dissolved oxygen levels, temperature, and pH throughout the harvesting process. Backup aeration systems ensure that equipment failures cannot compromise fish welfare during this vulnerable period. The transformation from live fish to consumer-ready products occurs in state-of-the-art processing facilities designed specifically for seafood processing. These plants must meet the most stringent food safety standards in American agriculture, with hygiene protocols that exceed those required for most other protein processing operations. Every aspect of facility design focuses on preventing contamination while maintaining optimal product quality throughout processing. Initial receiving operations begin with careful quality inspection of each batch of live fish delivered from farms. Trained inspectors evaluate fish for size uniformity, health status, and overall condition before accepting deliveries for processing. Any batches that fail to meet strict quality standards are immediately rejected and returned to the farm for further evaluation. Approved fish are transferred to live holding systems within the processing plant, where they can be maintained in optimal conditions until processing begins. These systems use the same advanced water quality management technologies found at production facilities, ensuring that fish remain in peak condition right up to the moment of processing. The stunning and bleeding process represents the first step in converting live fish to processed products. Modern facilities use electrical stunning systems that immediately render fish unconscious, ensuring humane treatment while optimizing product quality. Proper stunning is critical to preventing stress-related biochemical changes that can negatively impact flesh quality and shelf life. Bleeding procedures remove blood from fish tissues to improve appearance and flavor of finished products. Specialized cutting techniques sever major blood vessels while fish are suspended in chilled water systems that rapidly cool tissues and promote complete blood removal. This process must be completed quickly and efficiently to maintain optimal product quality. Scaling operations utilize mechanical scaling machines equipped with rotating brushes and high-pressure water jets to remove scales completely without damaging delicate skin tissues. These industrial machines can process hundreds of fish per hour while maintaining consistent quality and minimizing labor requirements. Removed scales are collected for potential use as byproducts in various industrial applications. Primary processing lines employ sophisticated cutting equipment operated by skilled technicians trained in seafood processing techniques. Whole fish are processed into various retail formats, including whole-dressed fish, fillets, and steaks according to customer specifications. Automated cutting systems ensure consistent portion sizes and optimal yield from each fish. Filleting operations represent the most technically demanding aspect of tilapia processing. Skilled workers use specialized knives and cutting techniques to remove maximum amounts of flesh while minimizing waste and maintaining attractive product appearance. Modern filleting lines can process thousands of fish per hour while achieving yields exceeding 65%. Secondary processing operations transform primary cuts into value-added products, including breaded fillets, seasoned portions, and ready-to-cook items that command premium prices in retail markets. These operations utilize additional equipment including breading machines, seasoning applicators, and portion control systems that create consistent products meeting exact customer specifications. Quality control procedures throughout processing involve continuous monitoring by trained inspectors who evaluate every aspect of product quality including appearance, texture, temperature, and microbiological safety. Sophisticated testing protocols screen for potential contaminants while ensuring that all products meet or exceed regulatory requirements and customer expectations. Temperature control throughout processing is absolutely critical to maintaining product safety and quality. Chilled water systems maintain temperatures just above freezing throughout all processing operations, while ambient temperatures in processing areas are kept below 50 degrees Fahrenheit. Digital temperature monitoring systems track conditions continuously and alert managers to any deviations that could compromise product integrity. Advanced cleaning and sanitization protocols ensure that processing equipment meets the highest hygiene standards between production runs. Clean-in-place systems automatically clean and sanitize processing lines using food-grade chemicals and high-temperature water rinses. These automated systems reduce labor requirements while ensuring consistent cleanliness standards that exceed regulatory requirements. Waste management systems capture and process byproducts generated during processing operations. Fish heads, bones, and trimmings that represent approximately 35% of live weight are processed into valuable secondary products, including fish meal, fish oil, and collagen, rather than being discarded as waste. The packaging phase transforms processed tilapia into consumer-ready products using sophisticated automated systems designed for seafood applications. These systems must maintain strict temperature control and hygienic conditions, while creating packages that protect product quality and extend shelf life through distribution and retail storage. Individual quick freezing systems rapidly freeze individual fillets and portions to temperatures below -10 degrees Fahrenheit within minutes of packaging. This rapid freezing process preserves cellular structure and prevents formation of large ice crystals that can damage product texture. IQF products maintain optimal quality for over 1 year when stored at proper temperatures. Vacuum packaging systems remove air from packages and create hermetic seals that prevent oxidation and extend shelf life significantly. Modified atmosphere packaging replaces air with precisely controlled gas mixtures that inhibit bacterial growth while maintaining product appearance. These advanced packaging technologies allow tilapia products to maintain peak quality throughout extended distribution cycles. Automated weighing and portioning systems ensure that every package contains exactly the specified weight of product while minimizing giveaway that reduces profitability. These systems can process thousands of packages per hour while maintaining accuracy within fractions of an ounce. Rejected packages are automatically diverted for reprocessing or alternative packaging formats. Labeling systems apply detailed product information, including nutritional facts, handling instructions, traceability codes, and regulatory compliance information required by federal agencies. Advanced printing systems can apply multiple labels per package while maintaining perfect alignment and adhesion quality, even in the challenging cold and humid conditions of seafood processing facilities. Case packing and palletizing systems organize finished products for efficient storage and transportation. Automated systems stack packages into shipping cases and arrange cases on pallets according to predetermined patterns that maximize truck loading efficiency while protecting products during transport. Robotic palletizing systems can handle thousands of cases per hour while maintaining perfect stacking patterns. Cold storage facilities maintain finished products at optimal temperatures throughout the distribution process. These warehouses utilize advanced refrigeration systems capable of maintaining temperatures below 0 degrees Fahrenheit while accommodating the massive volumes of product generated by large processing facilities. Automated storage and retrieval systems maximize storage density while maintaining first in first out inventory rotation. Distribution networks transport tilapia products to retail stores, restaurants, and food service operations across the country using temperature-controlled logistics systems. Refrigerated trucks and containers maintain cold chain integrity throughout transportation while advanced tracking systems monitor temperature and location continuously. Any deviations from optimal conditions trigger immediate alerts that allow corrective action before product quality is compromised. The versatility of tilapia processing generates numerous valuable byproducts that create additional revenue streams while minimizing waste. Fish heads and frames that remain after filleting operations contain substantial amounts of protein and calcium that can be processed into high-value ingredients for animal feeds and human nutrition products. Fish meal production utilizes rendering systems that cook fish byproducts at high temperatures while removing moisture to create protein-rich powders containing over 60% protein. These products serve as valuable ingredients in aquaculture feeds, pet foods, and livestock nutrition programs. The rendering process also generates fish oil rich in omega-3 fatty acids that serves premium nutritional supplement markets. Collagen extraction from fish skins and bones produces high-value ingredients used in cosmetic and pharmaceutical applications. Tilapia collagen possesses unique properties that make it particularly suitable for biomedical applications, including wound healing products and injectable cosmetic treatments. This emerging market commands prices many times higher than traditional food products. Bone meal processing converts fish skeletons into calcium-rich supplements used in animal nutrition and organic fertilizer applications. The high calcium content and excellent digestibility make tilapia bone meal particularly valuable for poultry and aquaculture feed formulations. Scale processing generates materials used in various industrial applications, including biodegradable plastics, adhesives, and cosmetic ingredients. Research continues into additional applications for fish scales, including nanotechnology applications that could create entirely new markets for these previously discarded materials. The culinary applications of tilapia continue expanding as American consumers appreciate its mild flavor, versatile cooking characteristics, and affordable price point. Fresh tilapia fillets appear in grocery stores nationwide, typically priced 30 to 50% below premium fish species, while offering similar nutritional benefits and cooking versatility. Restaurant applications range from casual dining establishments serving breaded tilapia dinners to upscale restaurants featuring tilapia in sophisticated preparations that highlight its delicate flavor and firm texture. The consistent availability and predictable pricing of farm tilapia make it particularly attractive to food service operations that require reliable supply chains and controlled costs. Value-added products, including seasoned fillets, stuffed preparations, and ready-to-cook items continue gaining market share as busy consumers seek convenient meal solutions that don't sacrifice nutrition or flavor. These products typically command premium prices while offering processors higher profit margins compared to basic fresh or frozen products. International cuisine applications showcase tilapia's versatility in dishes, ranging from traditional African preparations to modern fusion creations. The mild flavor profile makes tilapia an excellent canvas for various seasonings and cooking methods without overwhelming delicate flavor balances. The nutritional profile of tilapia makes it an excellent choice for health-conscious consumers seeking high-quality protein sources. A typical 4-ounce serving of tilapia provides over 20 grams of complete protein while containing less than 3 grams of fat and just 130 calories. This exceptional protein-to-calorie ratio makes tilapia particularly valuable for weight management and athletic nutrition programs. Vitamin and mineral content includes significant amounts of phosphorus, selenium, potassium, and B vitamins that support various metabolic functions. The low mercury content of farm tilapia eliminates concerns about heavy metal contamination that affects some wild-caught fish species, making it safe for regular consumption by pregnant women and children. Omega-3 fatty acid content, while lower than some fish species, still provides beneficial amounts of these essential nutrients. Research continues into feeds and management techniques that can enhance omega-3 levels in farm tilapia while maintaining the economic advantages that make this protein source so affordable. The environmental impact of intensive tilapia aquaculture represents one of its greatest advantages over traditional animal agriculture. Land use efficiency is extraordinary, with intensive recirculating systems producing over 100 times more protein per acre than beef cattle while using minimal water resources and generating no environmental discharge. Water usage in recirculating systems averages less than 100 gallons per pound of fish produced, compared to over 1,800 gallons required for beef production. This remarkable efficiency becomes increasingly important as freshwater resources face growing pressure from population growth and climate change. Carbon footprint analyses show that tilapia production generates significantly lower greenhouse gas emissions compared to beef, pork, and chicken production. The efficient feed conversion ratios and reduced transportation requirements for locally produced fish further enhance the environmental advantages of aquaculture over land-based animal agriculture. Waste management in modern tilapia facilities converts virtually all organic waste into valuable byproducts, rather than environmental pollutants. Solid waste from fish production serves as organic fertilizer for agricultural applications, while water from recirculating systems can be used for irrigation after appropriate treatment. Energy efficiency continues improving through adoption of renewable energy systems, including solar panels, wind generators, and geothermal systems that reduce dependence on fossil fuels. Some facilities achieve net positive energy production through biogas generation from organic waste combined with renewable energy installations. The economic impact of the American tilapia industry extends far beyond the farms and processing plants that directly produce fish and fish products. Rural communities across the country benefit from the employment opportunities, tax revenue, and economic activity generated by aquaculture operations that provide year-round employment in areas where traditional agriculture may be seasonal. Processing facilities typically employ several hundred workers in positions ranging from equipment operators to quality control specialists, providing stable employment with competitive wages and benefits. These jobs often represent some of the best employment opportunities available in rural communities while requiring skill sets that can be developed through on-the-job training programs. Research and development investments by tilapia producers contribute to broader advances in aquaculture technology that benefit the entire industry. University partnerships focus on developing improved genetics, more efficient production systems, and innovative products that expand market opportunities for American aquaculture. Export opportunities continue growing as international markets recognize the superior quality and safety standards of American-produced tilapia. Premium markets in Asia and Europe pay substantial premiums for American fish products, providing additional revenue streams that support domestic industry growth. The integration of advanced technologies throughout tilapia production systems continues accelerating with implementations of artificial intelligence, robotics, and precision agriculture techniques adapted for aquaculture applications. Smart sensors monitor everything from water quality parameters to fish behavior patterns, optimizing production efficiency while maintaining optimal animal welfare standards. Genetic improvement programs utilize advanced breeding techniques, including genomic selection and selective breeding programs that continue improving growth rates, feed conversion efficiency, and disease resistance. These programs represent long-term investments that will enhance industry competitiveness for decades to come. Automation technologies reduce labor requirements while improving consistency and quality throughout production and processing operations. Robotic feeding systems, automated harvesting equipment, and computerized processing lines enhance efficiency while reducing costs and improving worker safety. Food safety protocols throughout the tilapia supply chain exceed requirements for most other protein sources, utilizing hazard analysis. Critical control point systems that identify and control potential contamination sources from breeding through retail distribution. Advanced testing protocols screen for chemical residues, pathogens, and other contaminants that could compromise product safety. Traceability systems track individual fish lots from specific breeding groups through processing and distribution to retail customers, enabling rapid response to any food safety concerns while providing consumers with complete transparency about product origins and handling. The future of American tilapia aquaculture appears exceptionally promising as multiple trends converge to drive continued industry growth. Growing consumer awareness of sustainability issues favors aquaculture over wild-caught fisheries that face increasing pressure from overfishing and environmental degradation. Population growth and rising incomes in developing countries create expanding international markets for high-quality protein sources, while domestic demand continues growing as American consumers seek healthy, affordable alternatives to traditional meat products. The versatility of tilapia in various culinary applications positions it well to capture market share from more expensive protein sources. Technological advances continue reducing production costs while improving product quality, making American tilapia increasingly competitive in global markets. Investment in research and development programs promises continued improvements in genetics, nutrition, and production systems that will maintain American leadership in sustainable aquaculture. From the carefully controlled breeding facilities where millions of tiny tilapia fry begin their journey through the sophisticated grow-out systems that transform them into market-ready fish, to the advanced processing plants that convert live fish into hundreds of different consumer products, the American tilapia industry represents a remarkable success story in modern agriculture technology and sustainable protein production. We've witnessed how traditional farming principles combine with cutting-edge technology to create an industry that efficiently produces high-quality protein while minimizing environmental impact and maximizing resource efficiency. The journey from genetically selected brood stock